morning, students. My name is Jose Emmanuel Odomagsa and I will be your math teacher for today. So before we will start our class, let us have a morning prayer first. So for those who are Catholic, you may now do the sign of the cross. In the name of the Father, the Son, the Holy Spirit. Amen. So you may now take your seats. So before we will start our activity, I want you to first observe our classroom rules. Observe social distancing and always participate in our activities. So in our first activity, I want you to split in your permanent groups. And we're going to identify these equations, whether they are radical equations or non-radical equations. So here is our first example. Can you guys see it properly? Okay, so number 1. Number 2. Number 3. Number 4. And lastly, number 5. So, do you guys already have your answers? So, let's see. The first equation, is it a radical or a non-radical equation? Group 1. Yes, correct. The first equation is a non-radical equation. Just going to this one out. So number 1 is a non-radical equation. Number 2. Group 2, yes. Correct. This equation is a radical equation. I'm just going to stick this one out here. So for our third equation, here, what's your answer, guys? Yes, group 2 again. Correct. The answer to this equation is a non-radical equation. Here again. Here, equation number 4. What's your answer? Yes, group 1. Correct. The answer is, it is a radical equation. And lastly, here's our fifth equation. So, what is your answer in this, guys? Yes, group 2? Correct. The answer is, it is a non-radical equation. Stick here. So guys, based on your answers, when can you say whether that equation is a radical equation or a non-radical equation? So, yes, you're correct. You can determine whether they're a radical equation or a non-radical equation based on the radical sign. So if an equation has a radical sign, it is automatically identified as a radical equation. Since you can now easily determine a radical equation, so now let us look back to its more simpler form called the radical expression. So for this activity, the two groups will label the parts of a simple radical expression based on the definition given below. So you have answer sheets here for the two groups to answer. I will give you 3 minutes. So I'm going to give this. Now since you have now the answer sheets, Your time starts now. So 3, 2, 1. 3 minutes has passed. So let us see your answers. So here, you see your answers. So congratulations, both the groups got correct answers. So let us see now the parts of a radical expression here. So you can see the radical here, the radical sign, the symbol that is used to represent the square root of a number. Next is the radicand variable, the number under the radical sign. So x, it could be x plus 1, x plus 2, so anything, x squared, anything, any number and variable under the radical sign. And the last part is the index. The index, the number 2 here. It could be 3, 4, 5, whatever, depending on the equation given. So if you can't see a number here in the index, it means that it means that the number there is 2. Just like when you put x, there's always an invisible number 1 on its left side. So if there is no number, it is always automatically understood that the number there is 2. So that is the parts of a simple radical expression. So I think we are now ready to proceed to our next activity. So in our next activity, I'm going to give the two groups the steps on how to solve the radical equation. What you're going to do is you're just going to follow the steps and answer the practice questions in your answer sheets. Then after that, you're going to post your answers here in the front and try to explain how you got your answer. So I will give the two groups 5 minutes to answer their practice questions. So I will give answer sheets. So your 5 minutes starts now. So 3, 2, 1. Time is up. So now we will now post our answers here in front and try to explain your answers. So we'll start with group 1. So group 1, please post your answer. Thank you, John. So the group 1 will now try to explain how they got their answer. So clap your hands for group 1. So now group 1 is finished. Now let's start with group 2 to post their answers here in front and try to explain their answer. So group 2, please. Post your answer here in front. Group 2, thank you, John. Thank you very much. So now group 2 will try to explain how they got their answers. So let's clap our hands for group 2. So now that the two groups have finished explaining how they got their answers, so let's try to check if they got the answers correct. So we'll start here in group 1. So first, isolate the radical. So were the group 1 able to isolate the radical? Yes. So why is the given same to step 1? Or vice versa? Why is step 1 same to the given? Because the given is already isolated. So there's no need to isolate more. So they got the group 1 got their step 1 correct. So now let's check for their step 2. Square both sides. So were the group 1 able to square both sides? Yes, they were able. So square root of x squared equals 2 squared. So their step 2 is correct. So let's check for step 3. Solve for unknown. So were the group 1 able to solve for the unknown? Yes. So square root of x squared, so x cancels out, then 2 squared can be written as 2 times 2, and 2 times 2 is 4. So x equals 4. So now let's check for step 4 if 4 really is the correct answer. So substitute the value of x in our given. So x here will now become 4. So it's going to turn into square root of 4 equals 2. So what is the square root of 4? So square root of 4 is 2. So 2 equals 2. Were they able to check their answers? Yes, absolutely. Because 2 equals 2. 2 is equal to 2. So correct. So their correct answers are 1, 2, 3, 4. So group 1 got perfect. Clap your hands for group 1. So now let's proceed to group 2. So let's check their answers if they got it right. So their given is square root of 2 plus 2 equals 6. So step 1, isolate the radical. So what they did is x plus 2 minus 2 equals 6 minus 2. So what they did is they subtract both sides by 2 to move these 2 to the other side. So now what's left is just x squared. So now x squared is equals to 4. Were they able to isolate the radical? Yes. So their step 1 is correct. So step 2, square both sides. So square root of x squared equals 4 squared. So were they able to square both sides? Yes, they were able. So step 2 is correct. So solve for the unknown. So square root of x squared, the 2's cancel out, so only square remain. Then 4 squared is equal to 8. Were they able to solve for the unknown? Sadly, yes, they did not able to solve for the unknown because square root of 4 is actually 16, not 8. So what they did here is they multiplied it by 2 instead of multiplying it by itself. So with their answer is 8, they continue to step 4. So they substitute the given. So if x is equal to 8, so what happened is square root of 8 plus 2 equals 6. So they transfer the 2 here in the other side. So they subtract both sides by 2. So square root of 8 plus 2 minus 2 is equals to 6 minus 2. So here in this step, so since 8 is not really a perfect square, so they factored square root of 8. So they find a perfect square. So they found a perfect square, which is 4 times 2 equals 8. So square root of 4 is 2. Then the other 2 will remain here as radicand. So is 2 square root of 2 equals to 4? So sadly, no. Since they weren't able to solve for the unknown, they also weren't able to check their answers. But let's clap our hands for group 2 for their great effort. So now for the questions. So is there any similarities in the steps using solving algebraic equations and radical equations? So the answer is yes. The only difference is the method on how to remove the square root, since you can't find this in algebraic equation. So other methods of solving is still applicable before and after you remove the radical sign. So the answer to the question is yes, there are similarities in solving algebraic and radical equations. So now we have 3 additional examples for us to solve. When solving radical equations, always remember the 4 steps of solving the radical equation. First is to isolate the radical. Second is to square the both sides. Third is to solve for the unknown. And fourth is to always check all your answers. So we have here our first example. So square root of x plus 2 equals 6. So now we're going to follow the 4 steps in solving radical equations. So we're going to do the first step. What we're going to do is to isolate the radical. So in order to do that, we must transfer the 2 to the other side. So in order to transfer the 2 to the other side, we must subtract both sides by 2. So it's going to turn to like this. So square root of x plus 2 minus 2 is equal to 6 minus 2. So now it's going to turn like this. So square root of x, since positive, so 2 minus 2 is 0, equals 6 minus 2 is 4. So now we've isolated the radical. We can do step number 2, which is to square both sides. So we're going to square the square root of x and 4. So square root of x, when squared, it becomes just x. While 4 squared is 16. So now let's check whether 16 really is the answer to our problem here. So we substitute the value of x to our given. So it becomes like this. So instead of square root of x, it becomes square root of 16. So square root of 16 plus 2 is equal to 6. So what is the square root of 16? The square root of 16 is 4. 4, and that becomes like this. 4 plus 2 is equal to 6. Now here we can see the answer. The answer to that we found, 16, is indeed correct. 6 equals 6.
They're grown like plants.
So now, the second question, what about this? What if you encounter problems like this? So 2 square root of x plus 3 is equal to 12. So we're going to follow the 4 steps again to solve a radical equation. So first, let's isolate the radical from the non-radical. But how do you isolate 2? Here, 2 is multiplied to the square root of x plus 3. So what we're going to do here is just the same as transferring. It's just the same as solving non-radical equations. So what we're gonna do is we're just going to divide both sides. So it becomes like this. So 2 square root of x plus 3 equals 12. So we're going to divide both sides. So divided by 2. So the 2's cancel out. Then 12 divided by 2. So 12 becomes 6, and we have left here x, square root of x plus 3. So why divide both sides? Because 2 is multiplied to square root of x plus 3. So when you want to transfer a constant that is multiplied by a variable, you must always divide both sides by 2. So that's why we divide both sides here. So now we have isolated the radical. We have left with square root of x plus 3 on the left side and 6 on the right side. So now we can proceed to do the step 2, which is to square both sides. So we're going to square the square root of x plus 3, and we're going to square 6 as well. So now, square root of x plus 3 squared, the 2's cancel out here. Now we have left with x plus 3. While on the other side, 6 squared is equals to 36. Because 6 times 6 is equals to 36. So now we have x plus 3 is equal to 36. So now, we squared both sides, we have to solve for the unknown. So what we're going to do is, we transfer the 3 from the left side to the right side. So what we're going to do here is, we subtract both sides by 3. So x plus 3 minus 3 is equals to 36 minus 3, which is 33. So x equals 33. Now let's check whether 33 really is the correct answer. So we substitute the value of x here to our given. So it becomes 2 square root of 33 plus 3 is equal to 12. So now what we're going to do is to add 33 and 3, the radicands. So it becomes 2 square root of 36 equals to 12. So now, what is the square root of 36? That's right, you're correct. The square root of 36 is 6. So now it becomes 2 times 6 equal to 12. Then 2 times 6 is 12. So 12 is equal to 12. So now we can prove that really the value of our x is 33. Because we've checked. That's why it's really important to check all your answers after you find the x. So now, here our third question. What if it's a cube, not an x? The 3 here, the index is 3, not 2. So, still, even if it's 3, we're still going to follow the 4-step rule. So first, we must isolate the radical. So, we must isolate the 2 here to the right side. So what we're going to do is, we're going to subtract both sides by 2. It becomes like this. Cube root of x plus 2 minus 2 is equals to 4 minus 2. So 2 minus 2 is 0, 4 minus 2 is 2. Now, so now we're left with cube root of x is equal to 2. So now we've isolated the radical. So now, because this is cube, we're not going to square both sides, but instead we're going to cube both sides, so that the cube root will cancel out. So here, cube root of x cubed, so these 3 will cancel out, and now we're left with x, and then the right side 2 cube. So now here in the left side we're left with x, while here 2 cube. What is 2 cube actually? Well, 2 cube is simply 2 times 2 times 2. So now we have it. So now let's multiply all the 2's together. So 2 times 2 is 4 times 2, 8. So now we found that x equals 8. So now we're going to confirm whether the value of x is really 8. So we're going to substitute the value of x into our given equation. So it's going to turn like this. So cube root of x x will turn into cube root of 8 plus 2 equals 4. So what we're going to do is, what is the cube root of 8? So if 2 cube is 2 times 2 times 2, if you see the pattern here, 2 cube is 2 times 2 times 2, then cube root of 8 is the opposite of that. So you can see here that cube root of 8 is just actually 2. 2 plus 2 is equal to
Why does
4.
his name change to Rubel X? Or from Rubel X to Rubelexia?
Now we've confirmed that the value we found, 8, is actually true. So using these methods, using the 4-step method, you can always find and solve any radical algebraic equations. Because we now have learned how to solve radical equations, let's have a board activity. So we have 2 groups here, so each group will have to pick one problem for their group to solve. So we have here square root of x minus 3 equals 2, or 2 square root of 2x equals 2. So one of the groups must pick one problem for their entire group to solve. So for your assignment, I have 5 questions here for you to work on. And remember, always remember and use the steps in order to solve radical equations. So that will be all. Goodbye class, and have a good day.